For the past 8 months, students at the California Academy of Math and Science have been developing advanced robotic technology. Building off past developments, this year's project will be the most complex robot contracted by the CARP initiative. The project could not be revealed until the deadline passed for students to drop the class. Every student had to fully commit to the project or drop out. But before D-Day, or drop day, the students had an opportunity to test the waters.
My name is Shayna Weldon, and I'm the program manager responsible for leading this impeccable and outstanding group of 40 seniors. This year, we are tasked with building a quadrupedal, semi-autonomous, self-configurable robot named Shere Khan. We had 8 months to make this mission come alive, and I can finally say we have accomplished our near impossible goal.
The EDD Flash Challenge was the first time that the students would be working with their peers. The challenge? Launch a large egg as far uphill as possible without it breaking. The contraption had to be fully mechanical, no electrical components, no larger than an 18-inch cube, and lighter than 6 kilograms. The two classes were competing for the prize of $500 of starting budget to jumpstart their project, as well as the liberty to pick one of the two robots they were going to build.
So the Flash Challenge would be the first project that the team did. At first, it seemed like the task would be impossible to accomplish, as launching something 17 feet was very far. However, as we moved further in the design process, we singled in on the rubber slings design, and it ended up being very promising, as we were able to launch the egg very far.
The competition grew near. Finally, launch day arrived.
5, 4, 3, 2, 1. Yeah.
The project was finally revealed. The teams would be building two different robots, Shere Khan and Corbett. Shere Khan would be an autonomous quadrupedal robot capable of self-configuration and population control through elimination. Corbett would be either a quadrupedal or bipedal autonomous robot that would hunt Shere Khan. Red team chose to build Shere Khan, leaving blue team with Corbett. It was time to start the real project. Seemingly impossible, the team had to quickly develop a solution. How are they going to build a robot so complex? How would it move? How would it see? How would it detach things to itself? Working together, the team would eventually design each component of the robot in time for Critical Design Review 1, Preliminary Design Review.
During the preliminary design review phase, Hyperion Industries was split into two teams, Forge and SparkTech. As the chief scientist of Forge, my job was to lead the team in designing the robot through a series of decision matrices and brainstorming. Our robot was based on an idea of legs that use a pulley system to operate, as well as cubes to modify the robot when needed.
It was time for Critical Design Review 1. Both SparkTech and Forge would present their robot designs to camp's teachers. For the teachers, it would be the first time any of them were learning about this year's CARP Initiative Project Challenge.
The web display will be made using Crossbar I/O, and
so with this with our system, one thing that we will do is that we will have a primary.
With the first checkpoint out of the way, both teams found themselves with some important unanswered questions raised by the teachers.
So after PDR, both teams had to come together. It was kind of really awkward because during the entire part of PDR, we didn't exactly think of Forge as an enemy team, but as a competitor that we kind of had to work against. So for SPS, we had to work together, not only physically, but we also had to bring our ideas together and make it into one manageable solution.
Back to the drawing board. Between now and the next checkpoint, the teams needed to figure out the answers to fundamental questions on how the robot would operate. With only a couple months until the next CDR, the team needed to get right to work. First, the teams needed to collaborate and design the robot that they would develop together. Both of the original designs from each team had their own strengths and weaknesses. The best aspects from both robots would be incorporated into the final design.
Okay, so being a member of the mech team, mostly just being organized. We had a lot of struggle because each person had to do their own CADs, and like some people were doing millimeters, some people were doing inches, so we had to make sure everyone did it in metric system, which was millimeters, and it was pretty struggle because like our PM would get mad at us, and so we had to make sure everything was correct and make sure also the versions we had were on the Google Drive. Anytime we made an edit, we had to make sure everything had that edit, which would take about 5 minutes after we were done with it, or at the beginning of a meeting, it will be 5 minutes. Also is that I personally didn't have 2017 CAD, so it was a struggle because we had to do step files to convert it back, and then we had to use the computers in the class we were in, which was 2015, so we were changing between 2015, 2016, 2017, but then I finally got 2017, and every one of us brought our laptops, so we had to make sure that everything was the same version, and it was pretty well. And there was that just pretty much this organization. Like the skills we had were okay. Like some people did their CADs different, and like it took longer. But besides that, everything else was just on organization.
The next CDR was SPS, or Systems Performance Specifications. The audience for this checkpoint was different. In addition to teachers, industry professionals from companies such as Northrop Grumman would be in attendance. It would be the first glimpse at the robot for the industry professionals. And coming from industry, standards were high. The pressure was on.
So following the events of PDR, we had to take into consideration a lot of the critiques made by the engineers that were present during our presentation. One of the most glaring critiques, however, was our leg design, which was originally a pulley system. The simple truth of the fact was that it just wouldn't work. So we had to go through an entire redesign process. By redesigning the legs, however, that changed a lot of our other components. For example, it changed their body, it changed the motors that we would have considered using prior, etc. And it was a really eye-opening experience because you realize that sometimes you have to take a couple steps back to catch up to where you need to be. Soon after, we decided to study an MIT robot by the name of Kangaroo Bot. And their legs are based off of a kangaroo, so it was made for jumping, which was one of the original criteria for our mission. However, the design was changed again actually right before PDR because we realized that one of the ligaments that we had added for support was actually restricting the movement. So we removed that hours right before the actual PDR presentation, and luckily for us it worked actually, so that's great.
The following months were tense, and a sense of defeat fell upon the team. There was an extraordinary amount of work to complete in a limited amount of time. The team had to make some tough choices when considering the actions the team would take towards the completion of Shere Khan. A prototype was conceived, and all design concepts possible were implemented into it. This prototype was missing key functionalities, as the team had neither the time nor the manpower to push all the aspects of the mission into the prototype. Despite all the struggles, by proof of concept, the team had a working prototype of Shere Khan, albeit a basic one. Proof of concept proved to be less than spectacular. As industry professionals pointed out flaws, the design of Shere Khan would have to be altered yet again. At this point, team morale was at an all-time low, and it became apparent that not finishing the project could be a reality. The team had to soldier on, making progress and improvements to prepare for Checkpoint 4, Expo. The fourth CDR is a showcase of the technology that Hyperion has been working on the whole year. Expo would be an opportunity to show off Hyperion's Shere Khan. With an entire room at their disposal, designing the layout and feel of the room would be no easy nor cheap task. The final CDR was the mission, where Shere Khan and Corbett would face off against each other. The goal evolved over the year to accommodate for difficulties of building the robot. At this point, the robots were expected to walk, use modules, and press the kill switch on the opposing robots. Unfortunately for Hyperion, disaster struck. The legs kept being redesigned to replace previous ones. However, this backfired, and when the mission came, Shere Khan could not walk. Crippled, Shere Khan was unable to do much, while Hyperion scrambled to make it work. Eventually, it became clear that fixing Shere Khan at the time would not be possible. The audience watched as Corbett successfully walked and attached modules with some human assistance. Though Shere Khan did not perform to expectations, as Mrs. Carpenter said, the robots are simply a catalyst for the students' development. What we gained from EDD was more than some robots. Through the stress, the all-nighters, the last-minute changes, and hours spent after school, as students of EDD, we've learned the meaning of teamwork, hard work, perseverance, and dedication. Thank you to our families, our sponsors, and especially Mr. Carpenter. Without your support, none of this would have been possible.